Given the diagram below, select all the following statements that are true. So, first thing you should do when you see a problem like this is draw the diagram. Don't want to be a hypocrite, so I'm going to move it up real quick and I'm going to draw it myself, because you're on the computer. You don't want to be just looking at the screen the entire time. You need to be doing something. You need to be writing on it, working on it. So draw it. It doesn't have to be perfect. And from the looks of it, we're not going to be doing any real math. We're just going to be confirming pieces of information. So we have A, B, E, C, D. Alright, so it looks like we have two similar right triangles. Similar. They're not going to be congruent because we know this triangle is smaller than the big triangle. So it's saying triangle ABC, is congruent to DEC. Well, the order is correct, but this is for congruency. Congruent. So what's being congruent is this. And what congruent means is same shape, size. It's the same size, but it's not the same shape, so that doesn't work. Then we have triangle ABC. ABC is going to be similar to DEC. Well, let's just see what we have here. Okay. Both triangles have a C. Good. And if we look at the figure, it's a straight line, and it's a straight line, so they're both perpendicular. We can see that by just looking at the figure above. So they're both perpendicular right angles. Well, they are going to be similar by angle because they both share point C and they both have right angles. And if you can't see that, just draw two triangles. So we have right here C is always going to be congruent to C, and then a right angle is always going to be congruent to a right angle. And the only reason why I know they're right angles, vertical line, horizontal line, vertical line, horizontal line. So the first one is going to be true. And remember, similar triangles means that they are going to have similar angles. And similarity, I'll write down here, similar, what it means for it to be similar is same shape, but different size. Okay? Now it's saying angle DAB, DAB, so DAB is going to be congruent to CDE. So let's follow that, what it's saying. Now we don't have highlighters most likely during the test, but DAB, oh, that's a bad pen. So we have DAB, which is a right angle. It's going to be similar to CDE, or congruent. Yes, they are going to be congruent because they're both the same angle. What about angle ABC? ABC is going to be congruent to DCE. So it's saying, if we look at the two triangles we drew, ABC, B, so let's focus on B, DCE, that angle. Well, B would be congruent to E, not C. So that one would not be true. Now, we're looking at the proportions it's set up. It's saying CD creates a proportion with DE, okay? So again, it's saying CD creates a proportion with DE. Okay, and then AC AB. Well, let's create a proportion statement based off our two triangles. So we know CA, if we do CA from the big triangle, would go with CD. And our extended proportion, AB, would go with DE. And then BC, big triangle again, would go with ED, or EC. Let's just see if anything matches up. So we have CD and AC. Okay, these are together. So we're looking at CD, AC. Order doesn't matter, you could flip it. And then we have CD, AC, and then DE goes with, so CD does go with AC, good, the top numerator, then DE, AB. So if we were to flip these, put DE over here, or CD's there, so AC would flip. If we were to flip these, it would still be the same statement if we did CD over AB. CD over AB is equal to AC over DE. That's a true statement using our proportions. Last but not least, we have CD over DE. CD over DE, so it's the top by the bottom. Okay. Then we're going AD. Okay, right away we can see that's not going to work because that's not even part of the triangle. So right away I know that's not going to work because we need it to be for the full. We don't know the proportions for half of it. So we know what's going to be true, the triangle similarity, this angle, and the proportions.